Okay, we're going to do a couple of really quick exercises just to give you an idea of how this works. It's going to show you that this stuff is just so basic. Really, just after maybe 2 examples, you should be able to pick it up. And you're going to notice that later on, when you're given even fancier versions, same thing, nothing new. Okay, so let's go ahead and start off with this. Now, remember what I said. You can already identify that these are recursive sequences because we have 2 and we have a starting value. Okay, so it says find the first 5 terms of this sequence. Okay, so what's the first term? Well, what it's asking us to find term 1, term 2, term 3, term 4, and term 5. Okay, term 1 is given. It's 3. Term 2 is just right here. Okay, and that's everything after. So term 2 equals n minus 1. So that means a of 2 minus 1 is 1 plus 7. And that just turns out to be 3 plus 7. And that just means 10. Okay? A3 is just A2 plus 7. And what's that? Well, that's 10 plus 7 equals 17. A4 is A3 plus 7. And that's just 17 plus 7. What's that? 24. And finally, A5. That's just A4 plus 7. That's just 24 plus 7. And that's 31. If we bring this guy out so that you can see that, you're going to notice that that's 3, 10, 17, 24, and 31. You notice that they each go, of course. You can notice another number of interesting things, including the fact that that one goes there by 7, and that's 7 more. You know, so lots of cool stuff. But anyway, now let's go ahead and go on to the next one. Okay. So, once again, this is recursive. And in this case, okay, this is a geometric sequence. Okay, so this is geo, and once again we write down our pattern. A1 is given; it's just 1. Okay, what is A2? Well, according to our formula there, it's equals to 2/3 of A of 2 minus 1 is 2/3 of A1. A1 is just 1. Okay. Oops. So that's just 2/3 times 1. That's just 2/3. What about A3? That's just 2/3 of A2. What does that give us? Well, that's just 2/3 times 2/3. Does that give us? It gives us 4/9. Interesting, huh? A4, that's just 2/3 A3. So that's just 2/3 times 4/9. And that's going to be 8/12. 27. And then we've got a 5, and that is 2/3 A4. Of course, that same thing. As you notice, it starts to get pretty repetitive here. Okay. 8/27. 16/81. So we've got 1/2, 4/9, 8/27, and 16/81. And you can do the same thing as that one, which is that you're going to notice that the ratio of, say, 2/3 over 4/9 is the same as saying 2/3 times 9/4. Okay. And that's going to be 3/2. We just did it backwards. That's why it doesn't look like 2/3. Instead, it looks like 3/2. But you'll notice the ratio is exactly the same. It's going to remain the same when you go in that direction. Okay. The point here, though, is you get a constant ratio. So, but our answer, which is what we really wanted to focus on, is right here for this one, and right here for this one. Okay, well, let's go ahead and go to the next style, which is the first 5 terms of these. As you can tell, these sequences are explicit. How can you tell? Well, go back to the other video if you weren't paying attention. These are explicit sequences, and they're pretty easy. So you're being asked for the first 5 terms. So we're going to go ahead and write out our terms again. A to the 1, A to the 2, A to the 3, A to the 4, and A to the 5. Okay. Now, A to the 1. When this, remember that this reflects the value that n has. So if it's 1, then that's 1. So this means that this is 2, okay, times 1 plus 3. Well, that's just 5. Okay. And A to the 2 is 2. N is now 2 plus 3, 7. So in this case, the first 5 terms are right here. Okay. Now let's go with the other example. Okay. So we've got A to the 1 equals 1 minus 1 times 1/2. Of course, that's 0. Okay, A to the 2. That's 2 minus 1 to the 1/2. And that just means 1/2. A to the 3. Okay, that's 2/2, which is just 1. A to the 4. is 3/2. And finally, a to the 5. Okay. As you can tell, this stuff gets pretty monotonous after a while, but the point is, you've got a simple formula. Once you understand how the rule works, you've done it a few times, you got to do it a bunch of times. I know the first few times it still seems kind of weird. At least you can follow the instructions, right? That's all you got to do. Okay, so now what we're going to do is we're going to go ahead and solve it in the other direction, which is we're given the sequence and we want to solve for a recursive and an explicit formula. Okay, so first of all, we figure the formula by setting it up. Okay, so we start with our A1. Of course, before we do that, we got to figure out, well, is this an arithmetic or is this a geometric sequence? This is going to tell us how we do the next, but well, let's see. From here to here, we multiply by 3 again. So if we multiply by 3, we already know that we have a common ratio of 3. Tells us that this is geometric. Okay, good enough. Let's go ahead and set it up. Okay, so right here we go ahead and set up. We say 1/9, which is of course our initial value. And then our recursive formula is going to begin here, but we don't start yet. We just start setting it up. So we say A1, how do we get to the next one? Times 3. So 1/9 times 3 is 1/3. Okay. We say A3 is, well, let's see, so that's 1/3 times 3. And that's going to be 1. So far so good. And A4. And that is A3 times 3, 1 times 3, and it's 3. And so it looks like, yep, everything seems to be following. We have 3 in common here. Whereas, notice this, okay, our A2 and our A1, that's telling us that the value of A is based on the value of the previous A. From A2, it's based on A1. We multiply it by 3. Okay, and I know sometimes this seems really hard to understand, but do it a few times and you're going to notice the logic of it. Okay, it's just the first times you see it, it always seems like it's written in hieroglyphics. Okay, but once we have that set up, we just write it the more common way, which is A to the n is 3 times A to the n minus 1. And of course, since it's recursive, we have to give ourselves our initial value. Always need those 2. Okay, remember that. Okay, let's go ahead and move to the next. And let's look at an explicit formula. Now, one thing that you want to remember, that explicit formulas are always a little bit harder to write because everything is compressed into a single formula. But sometimes that makes them better. So so 2 to the 9, then to 28, and to 65. Now I chose this because this is a little more challenging than your typical explicit formula. So if you can do this one, you'll be able to do most of the others. Okay. So first we want to look for something. Do we see a common ratio, or is this an arithmetic sequence? Well, I guess if we add 7 to that, I know I wrote 8, but that was wrong. I think I was distracted when I wrote that, so forgive me for that mistake. Anyway, 19 is 28, and then 28. Okay. Yeah, that should be 37. Okay. So either way,
even though my numbers there were wrong, we can tell that this is not an arithmetic sequence, and it doesn't even look like a geometric sequence, because it doesn't seem to share a common multiple. Or does it? Let's think. There's a little strategy that we can use that's called the shift. And actually, they do it all the time, so you may as well get used to it, okay? Which is, if we can move the numbers in one direction, either plus or minus, okay? And let's see, do we see a pattern? Well, if you're aware of your numbers, you should notice that once we subtract 1 from them, you get 1, 8, 27, and 64. And I know you may not immediately have caught that, but these are all cubes, okay? 1 cubed, 2 cubed, 3 cubed, and 4 cubed. Well, this is great. You're like, oh, well, what does that do? Well, we just rewrite our equations over there. So 1 plus 1 cubed is 2. 1 plus 2 cubed is 9. 1 plus 3 cubed, well, that's 28. 1 plus 4 cubed, and that's 65. Again, forgive me for having written that other mistake. Okay, but at least everything else works out. Now, let's go ahead and start setting up our formula. First, we look for the things that do not change. Okay, so that's just whatever doesn't change is going to remain exactly the same. And what does change, we want to see if it changes exactly at the same rate that n changes, or as a ratio of n. Okay, well, look at this. A1, 1, A2, 2, A3, 3, A4, and 4. Well, that's wonderful. It looks like we're good to go. This is from here, it's just, let's go ahead and put it together. A to the n equals 1, the one that doesn't change, and the one that changes is just n cubed. Now notice, we just set this up based on our logic here, but we had to lay it out. That was a great move. Now, let's go ahead and test this, okay? Okay, so let's see. Okay, so we were asked what is a to the 5th. Well, we weren't, but we just want to see what's the next one. A to the 5th, well, that's just 1 and 5 cubed. And 5 cubed is 125. So we got 126. Fantastic. Okay. Well, one of the things you want to look for, like I said, when we set these things up is, first of all, lay out your numbers, okay? So that we can then much more easily look for a pattern. Okay, it's the pattern that's going to get us to the equation. And I know the first times you do this, you're not going to find anything. It's just going to be like, oh my God, I can't figure. I mean, unless I literally hand it to you, you're going to be suffering. But you know, that's just the way of math. So I know it seems like it's impossible, but it's not. Okay. Now, let's look for a connection, of course. Like I said, in this case, our blue squares tell us what is the connection with the ends. Okay. You can see A1 and 1, A2 and 2, A3 and 3, A4 and 4. Great. Let's go ahead and try a bonus example now. Okay. So we're going to try an even more interesting example. Okay. So again, I mean similar, but we've got 2, 16, 12, and 20. And our additional question is, what is a of 10? Well, our first step is just like always. We lay out the sequence. Okay, so we've got A1, A2. And here we're just kind of laying out what should be happening to it, okay? Nothing much. We're just kind of brainstorming. So we might even make mistakes. The point is, let's lay it all out. This is so important. And many times when you're doing these sequences, the number one reason you will not get it is because you are too lazy to lay this out. Too lazy. Write this. Write it all out. I can't overstress it. Write it out. Okay, so far we tried this and we're seeing, okay, well 2 plus 4, 6 plus 6, 12 plus 8. Do we see a pattern? No. Okay, well let's go ahead and see if we can do a shift. Can that help us find something? Okay, well let's go ahead and see. Okay. If we subtract 1, we get 1, 5, 11, 19. And like I said, we're just trying things here, so we're still not sure. Just like in any kind of puzzle, you just kind of try stuff on, and if it fits, you use it. If you don't, you change your approach. Part of what you're developing here is the ability to see and manipulate these numbers to get the right answer. So now we're like, oh, well, you know what? Why don't we do this? 2 plus 4 is 6. Okay. Well, the next one is 12. 1, 2. Why don't we try 3? And if we do 3, well, that's 9. Well, look at this. These numbers just go up by 1. And if you paid attention, you're going to notice that the second row is a bunch of squares. 1 squared, 2 squared, and 3 squared. Well, let's see. Does that logic follow? 4. That would be 16. What does that give us? 20. Well, lo and behold, we've got our sequence. Great news. Okay, so let's go ahead and write the a values, because that's going to tell us how to connect that to the n. Remember, our explicit formulas are always in terms of n. We have a4. We have a 4 there. We're going to kind of clean it up just so that we can see if we can find that pattern again. Okay, so we're just rewriting everything here. Okay, but we're writing it as squares. See, that makes it easier for us to detect our pattern. Okay. There's 1, 1, and 1. Does it change? Yes, 2, 2, and 2. 3, 3, and 3. 4, 4, and 4. And our 2's, of course, do not change. You notice, so they're going to stay constant. Well, then, great. So our formula then, it's simple. Okay, everywhere we have an n, we replace it and we put an n there. Another n squared. Fantastic. So you notice we tried everything. Now, what is a of 10? Well, once we have our formula, this is super simple. I mean, it's 10 plus 10 squared. Well, that's just going to be 10 plus 100. And that's just 110. Super simple. So, let's go ahead and wrap it up. Okay, we've been here long enough. So the point of all of this, and what I really want you to take from this, is when you want to create your equation, lay it all out. Okay, write out your numbers. Don't be lazy. Write them out. And if it doesn't work one way, try another. If it doesn't work another way, try a shift. See if that helps. There are other strategies too that might be a little more challenging. So don't just think these are the onlys. Keep looking and see and try something else. Just like working a puzzle, you're working ways to try to get it to work. Okay, but do not forget the number one rule. Lay it out and try some variations. Okay. Okay, guys, go ahead and try the exercises, and we'll talk soon. Bye.